Hello, this is Professor Salahat, and in this video here, I will try to show you how to work with homework 7, chapter 9, and we're going to go to numbers. We start with number 8 here, and in number 8, it talks about it tells us to calculate the correlation coefficient R. So we're going to calculate the R, letting row 1 represents the X values and row 2 represents the Y values. So the first thing I need to do really is copy my data into StatCrunch. So I'm going to go in there and click on this icon here to the right of the table. And then it says open in StatCrunch. So my data went to StatCrunch. And in the question, they ask us to find or calculate the R. So to calculate the R, we're going to go to Stat, Regression. In all of this chapter 9, it is regression questions. So we're going to go to regression and simple linear. And again, we need to pay attention here because they say let row 1 represents the X. So when you go to the X, you pick row 1. And let the Y represent row 2. That is what they are telling us to do in this question. Okay. So in here it says let row 1 represents the X and row 2 represents the Y. And that is exactly what I did in here. So after that, they ask us to calculate the R. So when you hit compute, just fill row 1, row 2, or variable X and variable Y, and hit compute. And that is the summary that we get. And that is the R there, the correlation coefficient R. And in our problem here is going to be 0.07, and they want us to 3 decimal places, so we're going to put 4. So we check the answer, and it's a correct answer. Now, in the second part of the problem, say, okay, calculate the correlation coefficient R, letting row 2 represents the X. Now, we need to really go and start from scratch and go to Stat, Regression, Simple Linear. And when it comes to X, we want X to be row 2. And we want the Y to be row 1. So again, according to the tell us in here, row 1 will be the Y and row 2 will be the X. And we did that, row 1 and row 2. So just go to compute. And notice that the R in this example, still the correlation coefficient R is unchanged, which is 0.074. It is the same R. So this just to tell us that R is by definition is the measure of strength of the relationship. And if there is a relationship between two variables, X and Y, so the strength of the relationship between X and Y is the same as the relationship between Y and X. So it doesn't matter if you flip this around, it doesn't matter. The correlation coefficient R will be unchanged. It will not change if you flip the columns. Notice that this is true if we are dealing with R. Later on, we're going to discover that this is not true if we are talking about equation, because in here, notice that in the summary, we get also equations. So that is not true for an equation, but it's true for R. So we check the answer, and it's good. Now we go to number 9 in here, and number 9 here, it says two variables have a positive linear correlation. Now, what does that mean? It means that here's we have the scatter plot, and it means that there is a positive linear correlation. It means that when you look at the dots, let me make this a little bit bigger here. When you look at the dots, notice that the dots are climbing, going up. That is what we call positive linear correlation. Now, the question after that is saying, is the slope of the regression line positive or negative? So here is the line that I put in red. Now, what is the slope? By definition, the slope is rise over run. So the slope is rise over run. So this is the rise, and this is the run. And notice that the rise is positive, and the run is positive, and the slope, which is M, that we learned long time ago is going to be a positive divided by a positive, which is still going to be a positive. So if the correlation is positive, then the slope must be positive also. So the slope is not negative in part A, it's not negative in part B, it is positive. It's going to be either C or D. If we read in here, it says as the independent variable increases, in other words, the independent variable is X. This is the independent variable X. As X goes up, as we go towards the right, the dependent variable, which is the Y, goes up. So again, this is the X-axis and this is the Y-axis. Okay, so as we travel into the right with X, Y goes to the up also. So in this case, as the independent variable increases, the dependent variable, which is Y, tend to decrease. That's not true. It's not decreasing, it is increasing. As the independent variable increases, the dependent variable tends to increase also. So that is the correct answer. Now let's go to the next one. In the next question here, we're going to talk about how can we use a set of data and go from there to predict other values. This happens all the time when you buy your car insurance, when you buy your home insurance, when you buy your life insurance, when we make decisions about enrollment in a college or something like that. We look at the past, we look at already things that happen already. So in this example here, it says find the equation of the regression line for the given data. Now in this data here, they monitored a total of 1, 2, 3, 4, 5, 6 people. And they looked at how many hours spent studying, and then they looked at their score, and they recorded that. Now, the question in here is asking us to come up with a prediction equation. This way, we can predict the values for other people who studied and how much they're going to get on the test. So, if you open the data here click on the icon here, open it in StatCrunch, this is our data. Now, they want us to find the equation. And to make it easy on us, they called the hours of study. Let me move this a little bit here. They called the hours of study X already, and the test score is Y. Notice that the score depends on how many hours you study. So therefore, that's the reason why I put the score under the Y key or the Y column, and the X or the hours of study under the X column. Because hours of study is independent. You decide how many hours to study, but you don't decide the score. The score depends on how many hours you study. So the question is here to find the prediction equation. We go to stat, and we go down to regression, linear, as we did before. For X, we're going to choose the hours of study, which is X. And for Y, we choose the test score, which is Y. Now remember, in here they wrote X and Y, just make it easy for you to match X with X and Y with Y. Now, when we hit, before I go further, okay, you know, they are asking me to do some predictions. So let me move this around. They are asking me to find the equation and at the same time to make some predictions. When X is 3, like, what if somebody studies 3 hours? What do you think they will get? What if somebody studies 14 hours? What do you think they'll get? And so on. So before I go any further, I want to just add something in here. And that is, before you make any decision, look at the X minimum in your table. Always look at the X min and look at the X max. Now the X min is 1. The least number of hours studied is 1. And the maximum number of hours studied is 6. Now, because our study is limited to people who studied between 1 to 6 hours, if we go in here and try to predict, we can predict, again, let's list the 3.5. The 3.5 will be predicted because it falls between 1 to 6. The 3 can be predicted because it falls between 3 to 6. The 2.5 can be predicted because it falls between 3 and 6. But the X equal to 14 cannot be predicted because it is outside our range. And if we try to predict how much a student will get after studying for 14 hours, our prediction will be not accurate, not reliable. And that is the reason why we will not predict for 14, but we're going to predict from 1 to 6. Okay, so how we do the predictions, let me bring this up here. To do predictions, go down in here and down all the way to says, where is the prediction of Y? And they're optional in there, list the predictions they're asking you to do. So the first one is they want us to do 3. We type 3. Then after that, we put a comma. Then after that, 2.5. We put 2.5. Then after that, we put a comma. And we put, then after finally 3.5. Notice that I did not put 14 in the prediction. I just put the 3, the 2.5, and 3.5. Forget the level here. The level doesn't make any difference in here. We're not going to use it. So when we hit compute, now we're going to get lots of results. The first result we're going to get is the equation. Notice that here is our equation. Now the equation is not written in this format. So let me show you how we write the equation in the same format. The equation we get, it says test score Y equals to 36.466 repeating plus 5.4 times hours spent studying. So let me say right in here, hours, okay, I'll write it X. Notice that to write this equation, we're going to write, here's the equal. Instead of saying test score Y, we're going to say this is Y hat. Y hat means the predicted Y. Y hat is equal to, and in the problem they want us to write to 3 decimal places, is going to be 36.467 plus, and instead of saying the hours X, we're just going to write X. So it's going to be 5.4. And again, they want 3 places. There is nothing else to add in there because the problem gave us 5.4 exactly. So this is my prediction equation. So I'm going to go in there and type the equation. But notice in here, they tell us to write the X first. So we're going to write the 5.4 first, 5.4X, and then we're going to write the 36.467 next. Okay, we can flip those around. And when we hit check, let me go back to the equation. It's telling me there is something. There is a tricky thing in the problem here. It says write the slope to 3 decimal places. Now notice that this is the slope. This is here 5.4 is our slope. They want it to 3 decimal places. 3 decimal places means you're going to add 2 zeros, but you don't have to add the 2 zeros. It's okay. That is the slope. Now this is the intercept. They don't want the intercept to 3 places. They say in here, round the y-intercept to 2 decimal places. So that number, we want it to be only 36.47. We don't want 3 places. That is just something they are trying to be clever with, and they added that. So that is, again, when you do the homework, just pay attention to that. They want you to make 2 different roundings in here. Now let me go back to the graph that the equation here. Notice that this is the equation we got. Now they want us to come up with a graph. You don't have to go and graph the problem. If you click on the right arrow in the bottom there, it will show you the graph. So when you look at this graph, automatically you're going to dismiss the graph that is coming down, like B is dismissed and D is dismissed because both of them are going down. So we're going to look at it's either A or C because both of them are going up. Okay, so which one of the 2 graphs is our graph? Now, there is one thing you can do here, which is click on this icon, what I'm pointing to, and create a full screen. And in here, let me just make this large enough for you to make the comparison. If you look at the graphs in here, notice that the graph doesn't match because the correct graph in the right side has the last dot is above the line. Here, the last dot is under the line. This is not a good one. Okay? Notice another thing is the front 2 dots, one is above, one below. And here it is both below. So when we look at the graph A, is not a good graph. Now let's look at the graph C and C. When you look at the graph C, notice that graph C is a good match in here because graph C has the two dots, one under, one above, above, under, above, and above. So this is the correct graph C. When we check the answer, it's going to give us the correct answer. Now, the next question or the next part of the problem will be, and by the way, you can go back in here by pressing the arrow. Now, in here, they tell us go back and it tell us the values at x equal to 3. We already predicted. Here's the predictions. At x equal to 3, we get 52.666 repeating, which is 52.7. They want us rounding this to the 10th. In the next question, they say, okay, what about the 2.5? At 2.5, here is a 2.5. The answer is going to be 49.9666, which is the same as 50. So now the one after, they tell us to predict at 14. Notice that at 14, I did not predict because 14 did not fall between min and max. Therefore, I am going to click on not meaningful because if I do make a prediction, my prediction will be wrong. Even if I get an answer, it's going to be a wrong answer. Finally, what do you get when 3.5? Here's a 3.5. A 3.5 is going to be equal to 55.366, which is 55.4. So here's how we do this problem. Let's go to the one after. Same idea for the one after. For the one after, they give us a table here where they said in here that this data here represents the length in centimeters and girth in centimeters of 12 harbor seals. So they measure the length and measure the girth, and they give us this data. And the first thing is they tell us come up with a prediction equation. So to do that, I open the StatCrunch, copy this into StatCrunch, or open into StatCrunch, and I need this one slightly for a minute. Then after that, I'm going to go to stat, regression, let me repeat, regression, symbol linear, and x will be length, and variable or the variable y will be girth in this case. And again, in the same problem in here, before I finish, let me just do those all together. In this problem here, they're asking me to get the equation and make predictions. Okay, I need to predict, like if we go ahead and find a length of a Harper seal to be 140 centimeter, what is the girth? If we get one with 172, what is the girth, and so on. Notice that I need to make 4 predictions. But before I make the 4 predictions, I need to look back in here. Look at the min and look at the max for x. Now we're looking at the variable x. So when you look at the variable x and look in here in this list of table, you're going to notice that the min is 125. And I can be wrong, but I'm trying to be careful here. 125, yes. And the longest one is 168. Okay, so in here they're asking me to predict 140. We can say, and another thing, 172, 164, and 158. So we can say here for 140, we can predict because 140 is between 125 and 168. 172 cannot be predicted because it's above 168, outside the range. 164 can be predicted because between 125 and 168, and 158 also can be predicted. So let me go back to here. I'm going to go down to where it says predict the y. I'm going to put 140, comma, 164, comma, 158. So I'm going to predict for 140, 168, or 164, sorry, and 158, but I'm not going to predict 170. When it gets to 170, I'm going to say I cannot predict if I do predict, my prediction will be not accurate. It's not reliable. So compute in here, and you get the results that you're looking for. So let me go back in here. What is the equation? Notice that Let me drag this and this up. The equation that I got in here, and in blue, y hat, or the girth is, notice that we're going to start with the x first. So we're going to start with the second part here, this part here. So we got the slope first. So the slope to 2 decimal places is going to be 0.692. So we're going to say 69. And what is the intercept is going to be 10.11. Because again, for the intercept, if you look in here, it's going to be 10.10, but there is a 9 after, so it's going to be 10.1. So when we go ahead and check here, it's going to give us the correct answer. The second thing is they ask us to show the graph. So to show the graph, just hit the arrow there. And the arrow there is going to show you the graph. It's not definitely, it's not going to be B or a D or a C. So it's not B or C. So let's see which one is going to be. And in here, it's just a fast look at this. You can tell that it's not going to be D, because in D, most of the points are under the line except 2. Where in C, there is point, or in A, points above and under. So A is the best match. And again, you can enlarge the graph to show you what's going on. And you can see that A will be a best match. So you're just going to choose, the A. And when you hit check, it's going to give you the correct answer. Now, let's go back to the arrow here to the predictions, because my predictions are there. So they tell us in here, predict the girth of a 140. So for a 140, here's the answer. 107, but they want us to put this to 2 decimal places. So it's going to be, for 140 is going to be 107 point. And again, I need 2 places, going to be 02. So check the answer. It's correct. Go to the next one. What about 172? Notice we didn't predict 172 because it's not meaningful. So it is not meaningful to predict the value of y at 172. Why? Because 172 is not an x value in the original data. That's not true. When you predict, you don't predict for original data. You predict for something you didn't even try. So because it is 170 is well outside the range. That is the reason why here C is the correct answer. Now the one after will be, what about for 164? For 164, we can predict it's going to be 123.63. Again, if you look at the prediction in this table, you get that for 164. And next will be, let me see in here. Next will be, what is the prediction at 158? 158 is going to be 119.119.48. So when we make those predictions, it's going to give us the correct answer. Now, the question after that is talking about this situation. They tell us use the scatter plot of the registered nurse salary data shown. What type of correlation, if any, do you think we have? Notice that for nurses, and this is the years of experience, and this is the annual salary. When they start close to 40, and the salaries goes up till around maybe 18 years of experience. Then after that, the salary will go down. Now, at first, when I looked at this problem, I can tell you that there is really no linear correlation. But in the book in here, when the person who wrote the question and added that, which is the publisher's question, they neglected to tell us up to 18. And that's the reason here is the answer should be really, by the way, the correct answer here is there does not appear to be a linear correlation. But that's not the correct answer, again, based on this. Based on this story, okay, the question is missing one part, and that is up to 18 years of experience. So in this case, there appear to be a strong, let's look at part A, a strong native. No, that's not native because it's going up. There appear to be a strong positive, and in part B, and in part C, it says there appear to be a strong positive linear correlation. So it's going to be either B or C up to 18. So the question that will follow will be, what do you think? Okay, what do you think the answer will be? As the years of experience of the nurse increases, the salary tends to increase. And that is B, really. As they work more, they make more. Because in C it says, as the number of years of experience goes up, the salaries tend to decrease. And that is not true. It's not decreasing. So we're going to choose B as an answer. But notice that I'm choosing B by looking up to 18 years of experience. Okay? Now, although after 18 it starts coming down, but in average, notice that we look at an average in here. In average, it's going to be going up. So if I have to put a line in here, the line will go probably, let me just minimize this one to show you. Like if I have to put a line here, like this is what I see. I see dots going like this. So if I will have to put a line in here, in average, my line is going to look something like this as I represented. So overall, even though it shows at the end that there is a dip, but overall, okay, this nurse makes more than this nurse and this nurse and this nurse and this nurse. So overall, there is an increase. So we're going to choose B as the correct answer. Now, let me do number 13. In number 13, and it seems like all of those problems they come up with, copy into StatCrunch, open in StatCrunch. That will make life so easy for us. And in here it says, find the equation of the regression line for the given data, letting row 1 represents the X variable and row 2 represents the Y variable. So again, I'm going to go to Stat. I'm going to go to regression. I'm going to go to linear. And they tell us, let row 1 be the X and let row 2 be the Y. That's exactly what they tell us. We want row 1 to represent the X and row 2 to represent the Y. And after that, they tell us just find the equation. So I don't have to go make any predictions in here. Go to directly after you choose row 1 and row 2, you go in there, and this is the equation of the prediction here. So let's continue here and see exactly what they want. They want the equation. So I'm going to copy the equation from there. Notice that if I write this one, as instructed, it's going to look like this. It's going to look like row 2 equal to 94.43 minus 4.12 row 1. But notice in the problem they tell us, don't call it row 2, call it Y. Don't call it row 1, call it X. Okay, but remember, when you call it Y, you're going to call it Y hat. Okay, so that is exactly what they want us to do. So in this case, I'm going to come in here and say, okay, and instead of row 1 here, I'm going to put X. So X goes first. And notice that the number in front of X is negative. So I'm going to start in here with the negative sign and put point or a negative 4 point. And again, in the problem, they ask us to do 3 places. It's going to be 1, 2, 4. And for the intercept is going to be 94.432. So this is what they want us to do. Just copy the equation, and that's a correct equation. Now, when we continue in here, they tell us, show us the graph. Here is the graph. So show us the graph. Automatically, I am going to dismiss graph C, because graph C and D, both of them, they're not dismissed, C and D are not dismissed. I'm going to dismiss A and B because A is going up and D is going up, or A is going up and B is going up. So the first two are dismissed. It's going to be either C or D. So which one it is? It is very obvious that it's going to be D, because if I look in here, the last 2 points are above each other. And then the points before is above the line and under the line, and like the lines are stacked and there is one far, far away. So it is obvious that it's going to be D. And when you check D, it's a correct answer. Notice again that if you cannot tell which one it is, you always click in here and on the pop out, and this will make the graph big for you to make a good judgment. Okay, now if we continue here, they say in the second part of the problem, they say, okay, we want you to change your mind now. We want you to let row 2 represent the x and row 1 to represent the y. So in other words, go back to the problem here, and when you go to the data regression symbol linear, we want row 2 to be the x and row 1 to be the y. Now let's hit compute, and I want to show you something. Okay, one thing will not change is r. R will not change from the previous example, but the equation will definitely change, because the equation now is going to look like this. Look, let's start with the x first. Now this is the x, and what is in front of the x is native point 118, because they want 3 places. And for the intercept, which is the intercept is in here, I'm sorry, 13 point, let me put this down, 13.345, because they want us to round to 3 places. Again, one thing I want you to notice, here's the equation, and here's an equation. By flipping the rows, we change the equation. R did not change, but the equation changed. Let's look at the graph, because I'm sure they ask us to show the graph next. Notice that the graph will change also, because in the first one, we put the x in here. Okay, we put row 1 in here, and this is row 2. Now it is the opposite. We replace row 2 with row 1 and row 1 with row 2. So if you look, you don't have to bother, just look at the here what the matches. B is not a match because going up. D is not a match because it's going up. It's either A or C. And if you look carefully, it's going to be the A, it's not the C. And it's the reason why, because if you look at C, the points in here above each other. So this is going to be the A. So this is the answer. Okay. Now, finally, what effect does switching the explanatory variable, or in this case x, and response variable, in this case y, have on the regression line? Okay, what is going to happen? So let me just put this down. Let me make this window large, and let me make this small for you to see. This way you can make the right judgment. You know, when we try to make things small, we don't make the right judgment here. So look at the 2 equations. Okay, so what effect does switching the explanatory and response variables have on the regression line? The value of B is unchanged, but the sign of the value of M is changed. Okay, notice that when we change the selection row 1 with row 2, look at the slope. In the first equation, the slope is -4. In the second equation, the slope is -0.188. So the slope changed. Look at the intercept. In the first one, 94.4. In the second one, 13.345. It is the slope also changed, and the intercept changed. So both the value of the slope and the value of the intercept changed. One thing that did not change is the sign of the slope. Look at the sign of the slope, native and native. So in here, they tell us the value of B, which is the intercept, is unchanged. That's not true. B was 94, became 13. It changed. The value of M is unchanged. That's not true. In the first one is -4. In the second one is -0.1. It changed. The sign of M is unchanged. That's true. The sign of M did not change. It's native. But what? In part C. But the value of M and B changed, and that is true. So this is the correct answer. The sign did not change. Native, but the values did change. So I don't have to continue with this. I'm going to check my answer, and it's a correct answer. So that is the answer to this problem, which is number 14. I'm going to stop with this here, and I'm going to continue with another video.